Welcome, everyone. I am thrilled to kick off our fourth and final installment of our inaugural year of this Sustainable Education Research Initiative virtual webinar series. My name is Matt Kraft, and I'm the founder and faculty director of Sustainable Ed. Our aim is to advance education-based efforts to create more resilient and sustainable schools. And we accomplish this by conducting policy relevant research, translating evidence into actionable insights, and serving as a national hub for cross-sector collaboration. It's my great privilege today to introduce to you our guest speaker, Dr. Claudia Persico. Dr. Persico is an economist whose research focuses on environmental policy, inequality, and health and education policy using causal inference methods. She is an associate professor of public administration and policy at American University and a research associate at the National Bureau of Economic Research. Without further ado, I will hand it off to Dr. Persico to take it away.
All right, great. Thanks so much. So the title of my talk today is How Pollution Can Harm Student Achievement and What Schools Can Do to Stop It. And so to start out, toxic release inventory sites, which are just factories and power plants and any place in the United States that releases more than 2,000 pounds of toxic pollution annually, are often all over, they're everywhere, basically. Pollution is everywhere. We're all walking around being exposed. And there's starting to be growing evidence that this is actually a problem. So we know that toxic release inventory sites like coal-fired power plants often release numerous developmental neurotoxins and exist in large population centers. So these are basically sites that are industrial and federal facilities that release pollution. And 2/3 of Americans live within 3 miles of one of these things. About 200 million people have one in their zip code, and at least 80 million people live within 1 mile of one of these things. And this is a map of where they all are. As you can see, they're in large population centers. The worry is that these are having really negative effects on children. So what do these things look like? Well, the top image is an image from Washington, D.C. This is one of our local cement mixeries that releases a bunch of lead. The bottom is just, a factory in the suburbs that, produces, I think this one is like a glass and metal manufacturer. The United States is actually a large manufacturing base still, and we produce a lot of different kinds of things. And this is one that is in Providence, Rhode Island. This is the one that's the closest to the Brown campus. I think it lights up at night. There were several pictures of the smokestacks glowing red in the evening light that looked very, very artistic and pretty. It looks like lots of people took pictures of this, but it's actually an old school power plant that's releasing a fair amount of pollution into the neighborhood. And actually, Providence is fairly polluted. So these are the TRI sites in Providence. Your air quality isn't really that great. You can see that there are at least 50 of these things really close into the city. So, particularly I'm concerned about like this stuff. And you can see that they're mostly concentrated in South Providence towards the airport, and then some in East Providence, but also some in North Providence. You're really kind of surrounded here. And this is typical. So we walk around being exposed to pollution in American cities all the time. This is, a legacy of the Industrial Revolution. When we built factories and power plants, we wanted them to be close to the city, and pollution is the sort of side effect of these things. And unfortunately, we know that at least 300 toxic chemicals affect brain development and can actually harm children. So toxic release inventory pollution is not the only game in town. There are also other types of toxic waste sites called Superfund sites that are in this map. So the ones that have X's on them are the ones that have been cleaned up. So Superfund sites are the worst of the worst federal toxic waste sites. So TRI sites, you can think of them as your ordinary factory that's releasing pollution kind of all the time. And Superfund sites are contaminated land or water. So there was a toxic spill somewhere, or the ground of a lot of places that used to be factories before there was environmental law end up being Superfund sites, because back in the olden days, before the EPA came on the scene in like sort of the late 70s, if you had some toxic waste, you threw it in the ditch out back. And so we ended up with a huge number of Superfund sites as well as toxic waste sites. It looks like Providence actually has several Superfund sites as well in its border. And right now, the Superfund program is completely out of money, so these things are not currently being cleaned up, which means that there's uncontrolled hazardous waste that's just sort of there that people or children can walk into and be exposed, and it's sort of a problem. So pollution exposure is common and inequitable. So Matt Kraft and Malik and Falcon find that 44% of schools are located within 1 mile of a Superfund site, a brownfield, or a TRI site. Brownfields are other toxic waste sites. They're just not quite as bad as Superfund sites. And so like companies are charged with cleaning them up. It's unclear like how good the cleanup of those things are, but you know, that this is like a problem that affects nearly half of schools. And my guess is that if you loosened that restriction of 1 mile, we know this stuff blows and affects people, you know, even at the zip code level, you would find that it's more than half of schools. In addition, over 6 million students attend schools within 250 meters of a major roadway. We know that highway pollution also affects learning. And then students attending schools near highway Superfund sites or industrial sites are disproportionately low income and students of color. So this is the exposure to this stuff is highly unequal. And some of it is because these things are in major population centers. They're in cities. And so if you're in a city, you're being exposed to some amount of toxic pollution in the United States. And so one of the points I want to make is that not all pollution is created equal. And so I'm going to be talking about kind of some of the worst offenders, the types of places that have lead and mercury and, you know, really, really bad stuff that we are worried about children being exposed to. And I should mention exposure to pollution, whether from nearby highways, industrial facilities, or poor ventilation, lowers test scores, increases absences, and worsens behavior. So I just want to go through a little bit of background. So there's actually been a lot of research on especially early exposure to schooling outcomes in K through 12 school. So we know that so it might be hard for schools to intervene on this kind of stuff because we know that prenatal exposure to pollution can harm test scores later on. So Nick Sanders has a study early on showing that county level air pollution during gestation affects later high school test scores in Texas. We have pretty good evidence at this point that lead poisoning can cause worse academic outcomes, so lower test scores, increases in crime as well, and also an increase in the likelihood that a student has special needs. So it can also cause cognitive disability because lead causes brain damage. And so if you're exposed to lead in early life, there's a high chance that you end up with some kind of sort of cognitive disability that potentially follows you for the rest of your life, that makes school hard for you, that makes it hard for you to control your emotions. Children who are exposed to lead are more likely to be suspended from school and things like this. And so Ferry, Rolfe, and Troskin used historical US data to sort of examine lead exposure and Army test scores during World War II, and they find negative effects. Azer, Curry, Simon, and Vivier used preschool lead levels to predict US test scores and find that lead does in fact cause worse test scores. Bardwaj, Gibson, Zivin, and Nielsen compare siblings who are exposed to different levels of air pollution in developing Chile and find effects on test scores. Almond, Edlund, and Palma use Swedish data on nuclear fallout to compare adjacent cohorts of children and find that those exposed to nuclear fallout from Chernobyl actually have way worse test scores and worse life outcomes. There's a follow-up paper on that. And then I have a paper with David Figlio that uses a sibling comparison to examine the effects of Superfund pollution on children's test scores, suspensions from school, and likelihood of cognitive disability. So essentially, what we do in this paper is we compare siblings where the first was gestating before the EPA cleaned up the local Superfund site, and the second sibling was gestating after. What we find is that kids within 1 mile, 1 to 2 miles, excuse me, have way worse test scores later on than their sibling who was not exposed during gestation. In addition, there's starting to be growing evidence on short or medium-term exposure to pollution on schooling outcomes. So that's exposure for kids who are actually in school. And so Dave Marcotte has a study on this. He uses a student fixed effects model to study, in the Eccles K, to study the effects of pollution and pollen on student achievement. This should be Evie Lavenstein and Roth, but basically there's a paper showing that if students take a very important test that determines postgraduate outcomes on a day of high pollution, they score lower on that test that they've been studying for all of college, and then they have worse job placements and have lower wages as a result. Hollingsworth et al. Uses the phase out of NASCAR leaded gas to show that lead exposure over a longer time frame also has worse effects than a single dose of lead. So he's looking at what happens when kids are exposed, in school, starting in kindergarten or pre-K, over like kind of a long time frame if they're near one of these NASCAR races, because NASCAR used to use lead and gas all the way up until 2007. And so because regular cars were regulated to be de-leaded, gas was de-leaded largely in the 80s and early 90s, but it turned out that there were some exceptions, and NASCAR was one of them. And then I have a couple of papers also on this. So I have a paper with Joanna Venators at Boston College where we use a difference in differences design where we basically compare a student to themselves before versus after one of these toxic release inventory sites opens or closes within 1 mile of their school compared to kids attending school farther away. And we find pretty large negative effects. So this is the next slide. Basically, this is time -1 is when the site opens, and you can see at time 0, test scores start going down for this treatment group of kids who are right near these toxic release inventory sites. The blue is kids right next to the TRI sites, and the red is kids slightly farther away but in the same zip code. And you can see that there's this big negative effect on test scores that kind of increases over time. In addition, I have another paper that looks at what happens when kids move from upwind of a highway to downwind of a highway. And so basically in the US school system, often kids have to switch schools when they're going from elementary to middle school or middle school to high school. So we use that kind of policy-induced school switching to show that when kids go downwind of a highway from, sort of upwind, their test scores plummet, right? And so if they go upwind, they don't really recover, but when they go downwind, they have this huge negative effect. In addition, when they go downwind, the likelihood that they get suspended from school skyrockets, and the likelihood that they repeat a grade actually is affected as well. And so, the evidence on this is that, this stuff is happening in schools, is that pollution is affecting kids as they're attending school, largely due to probably poor ventilation, not filtering the air, and all of this kind of stuff. And there's also evidence that this could actually accumulate and affect long-run outcomes like graduation, going to college, how much money you make as an adult. And so there are a bunch of different studies that look at this. So Eisen, Rossen, Slater, and Walker use these sort of non-attainment designations. So when the Clean Air Act came into effect in 1970, some of the counties were grandfathered in and did not have to immediately lower their air pollution. And those were called non-attainment districts. And so they compare the folks who had to lower their air pollution to the folks that didn't, and find that air pollution caused worse outcomes on wages and labor force participation years later. In addition, there's this Swedish paper that uses the phase out of leaded gasoline in Sweden. And they find that kids who are exposed, like not exposed to lead because the lead was phased out, had better wages, more education, and less crime compared to the ones that did get exposed to lead. So lead, this is one of the big lead crime papers. In addition, we know that radioactive fallout from Russian weapons testing can also affect IQ, educational attainment, and earnings. And also, there's this paper by John Voorhees that kind of also uses these non-attainment designations for the Clean Air Act and using census data, and also finds effects on wages, educational attainment, and incarceration. I also have a paper on this. Basically, I use, again, the opening and closing of toxic release inventory sites, and I compare siblings where one's exposed because, the site opened and they got exposed, or they were exposed because they were born before the site closed, and then the other one wasn't exposed. And I find, again, like this is based on an outcomes index where I kind of put in your adult wages, how much education you have, whether or not you have a cognitive disability. And I use children of the National Longitudinal Survey of Youth, which is very, very rich data that follows families over time. So I can see where kids are born and all this kind of stuff. And I find fairly large effects within 1 mile on poverty outcomes. I also find that pollution increases the likelihood that people are going to be on public assistance, whether that is temporary aid to needy families or food stamps or any of these kinds of public assistance programs, which are very strong indicators for being in poverty in adulthood. And I also find large increases in cognitive disabilities like autism and ADHD and other kinds of specific learning disabilities in this group. And it's because potentially these TRI sites can damage developing brains and cause these kinds of disabilities. So, oops, went the wrong way. So I just want to talk a little bit about the neuroscience background. I don't have a ton of time here, but not all pollution is equally harmful. So we know that heavy metals that are in Superfund sites and toxic release inventory sites disrupt many of the normal biochemical processes that are necessary to build a sound and durable brain in early life. So they disrupt neural migration and synapse formation. They disrupt neurotransmitters. They can actually strip the protective coating off of your brain cells. And we know they're neurotoxic in rats, but they're not actually specially regulated. So there's some lead rules, but there's a lot of other heavy metals that are just kind of pumped out without any special rules. We also know that polycyclic aromatic hydrocarbons, which is what comes out of the tailpipes of cars and what results from burning any kind of fossil fuel, are associated with lower IQ scores in children. They alter the level of neurotransmitters in the brain and are also neurotoxic in rats. Neurotoxic just means it kills brain cells. And then volatile organic compounds like nail polish remover or paint thinner. Those are really great examples of ordinary volatile organic compounds, but they're used in a lot of manufacturing processes as well. We also have this long-term associational longitudinal studies showing that these things are associated with poor neurobehavioral performance. And again, we know they're neurotoxic in rats. And so, when people are exposed also can matter. So if a baby is exposed while it's gestating, or a fetus is exposed while it's gestating, that can really disrupt these neural pathways and these early life formations. But it's also true that, being exposed in early life is super important. And so preschool exposure could be really bad. Particularly, we know this is terrible for lead poisoning. If you're exposed before the age of 6, you have a strong chance of having, some kind of neurological deficit from it. Potentially you need special ed, potentially your behavior is going to be altered and all of this kind of stuff. And, these higher cognitive functions are still developing over time. And so all of this is happening while children potentially are also school aged. And so kids are much more vulnerable to pollution than adults are. So it's important that we intervene. And also, schools are essentially already footing the bill for this. So the US spends $500 billion each year in public assistance programs to fight poverty. We know that 14% of the children in the US have disability, and that's rising. Congress capped the number of children who could be identified as special needs at 12%. So all of the extra cost of this is going to districts and states. schools spend a huge amount of money on special education. Children with learning disabilities cost about twice as much to educate. They're more likely to repeat grades and drop out. 19% of students with learning disabilities drop out of high school. And we know also that dropping out is very costly. And in addition, pollution causes cancer and respiratory problems like asthma. So you have these very high liabilities that schools are sort of having to deal with because of our sort of environmental policy not being quite what it could be. And this is so while overall air pollution has decreased over time, and it's important to note that we're actually good at decreasing pollution, the Trump administration, during the first administration, lifted key controls on toxic air pollution. In this administration, they did the same thing. They also suspended enforcement of environmental laws during the pandemic. I actually have a paper on this showing that it led to about 8,000 additional deaths from COVID. So I compared places that had more and fewer of these TRI sites, and the rollback of enforcement of environmental law, which was really a soft rollback in the sense that it was just about fines. The EPA said, oh, we won't fine you if you exceed air pollution standards. We won't enforce the Clean Air Act. And I find that this actually did increase pollution in places with more of these reporting sites, which were the specially regulated ones, and that led to more cases of COVID and deaths from COVID. In addition, the Trump administration right now, not to make this too political, but has just rejected the bedrock scientific finding that greenhouse gases threaten human life and well-being, which means that we can no longer regulate greenhouse gases. The reason that this is important is that all the places that are emitting greenhouse gases are also emitting these co-pollutants. They're all TRI sites. So we've essentially just deregulated TRI sites, which means that they're going to probably emit more pollution, and we've removed some of the Clean Air Act's ability to regulate this. In addition, the EPA weakened the limits on mercury and lead from these coal-fired power plants, which we know also is potentially harmful for children. So this is a really great time to think about what you can do to limit children's exposure to toxic pollution. So investments in clean air technology and infrastructure are among the most cost-effective ways that schools can boost academic outcomes and close equity gaps. So installing air purifiers increased test scores by 20% of a standard deviation, which is actually a very large effect. That's the same effect as having like a very small class under the Project STAR experiment. And at an annual cost of about $1,000 per school. So that's very cheap. Replacing HVACs or upgrading HVAC systems, according to Biasi, LaFortune, and Schulhauser, also produce the largest academic gains among capital investments studied. They also find about a 24% of a standard deviation improvement in test scores just from installing new HVACs, which is a very large effect on test scores. Similarly, school air quality renovations in Texas improved achievement by 15% of the standard deviation. And we also know that doing things like retrofitting school buses can have really important effects. So it turns out that a lot of old school buses emit a ton of pollution into the cabin of the bus. So kids are actually breathing a lot of diesel fumes while they're on the way to school, which can actually affect their brain and affect their performance in school. And so there's this paper that shows that in a district that retrofitted 10% of school bus engines to be cleaner, they increased test scores by about 1% of a standard deviation. So if you did, 100% of your school buses, you'd get, 10 times that effect, like 10% of a standard deviation, which is actually a pretty good sized effect just from retrofitting school buses. So you can retrofit them to make them cleaner. You can use the same bus and just do a program that does this. North Carolina has a program like this. There are a few states that have tried to do this. In addition, I don't know if I have time to really talk about this, but I have a paper that evaluates how we spent the elementary and secondary school emergency relief funds. So ESSER was a series of 3 grants provided to K through 12 schools. We gave them about $200 billion to address the impacts of the COVID-19 pandemic. And the funds were allocated based on the Title I program, which is the district level percent poverty from 3 years prior. The funds were meant to address learning loss and chronic absenteeism, ensure safe learning environments, and provide professional development for teachers and support technology needs. A lot of the money was actually spent on HVACs because the Biden administration at some point kind of came along and said, we think you should spend this on one-time investments. And so we evaluate what happened in North Carolina when schools put in HVAC. So we find that, about 500,000 students experienced an HVAC improvement in North Carolina. And there were about 500 schools that had these HVAC improvements over time. This is just sort of showing you how many schools a year got these HVACs. And we've actually extended this to 2024. And what we find is that, the schools that got HVACs and didn't get HVACs look pretty similar in the free period. But once the HVAC is installed, so in our case, the HVAC is installed in 2021, so we just limited to the 2021 HVACs. Suddenly, the treatment group does way better and recovers way more on their test scores than the comparison group. And so we find actually this stuff really matters in terms of recovery efforts from the pandemic. It turns out that if you treat a school by giving the entire school air purification and address the heating problem and cooling problems so that the kids are learning in a reasonable temperature and with clean air, this has dramatic improvements. And it's across the board because everyone's treated in the school. If you go to the school, you're going to breathe that clean air and you're going to experience that nice temperature. And so it has effects across race, across income. It's one of the sort of almost like miracle interventions that affects every kid, which is great. Oops, went the wrong way. So I don't think I have time to talk about this, but we did a bunch of different kinds of specifications. We find these across the board improvements, increases in math and reading scores. You can pool the test scores, you still find an effect. You can use a matched sample of schools who are almost identical and you find an even larger effect. You see a reduction in percent of days absent, a reduction in chronic absences. And if you like school grades more than you like test scores, you also find about 10% of a grade improvement. So this is our new paper that we're about to release that you get a preview of. But we find, in fact, that the ESSER money was very well spent on HVAC upgrades. Sorry, I keep going the wrong way. So another piece of advice for policymakers and teachers and people who are in schools, be proactive. Monitor pollution exposure at schools and conduct regular maintenance of HVAC and water systems to mitigate health risks and support early identification of issues. So a lot of school water fountains have been found to have lead. And so you should test your school water fountain to see if it has lead in it and offer potentially filtered water if lead contamination is found, because it turns out it probably affects your health. It probably affects the kids' health. Lead potentially can cause heart attacks. It's not great. Replacing lead pipes in school lead service lines is another potential intervention, and making sure that air and water filters are replaced on schedule, and that specifically you're replacing them with HEPA filters. HEPA filters are HEPA filters. They're essentially filters that actually filter out enough of the air pollution, and they also filter out viruses and bacteria, things that make kids sick. All of that stuff is super important. So practices to avoid ignoring the issue and not changing the filters, using low quality filters. As I mentioned, HEPA filters should always be used. If filtering water, filters need to be rated for lead removal. If you find lead in the water, not all filters will remove lead. They'll say right on the package. Citing schools on or near sources of pollution should also be avoided. So right now, we cite new schools where the land is cheap, and often the land is cheap because it's contaminated, or it's right next to a source of contamination, like factories, power plants, highways, Superfund sites, or the like. So we need to start really thinking about where we put new schools, and where we're situating children who, because where we put the schools might be counterintuitive to the practice of learning. So just to conclude, I realize that I'm probably out of time, but we know that low-income Black, American Indian, and Hispanic children are most likely to be exposed to pollution and suffer the worst consequences from it. Differential exposure to pollution is likely to be a major driver of economic inequality. Exposure to pollution is also extremely costly, and schools are already paying for much of this cost. And so by installing these kinds of things in schools, schools might be able to eventually balance their budget and get returns from this type of thing. To make matters worse, I have another paper that finds that having lead-exposed peers has negative spillover effects onto children who were not themselves exposed to lead, in terms of increased suspensions from school and lower graduation rates and college intentions. So lead poisoning affects everyone's kids. it's a public health disaster and it has spillover effects. And education policymakers are in a really unique position to act here. Oops. And also, we know that air purification upgrades can improve test scores, decrease absence rates and chronic absences from school, and improve grades. The effects are likely due to both improved air quality and decreased illnesses, and also it being a nicer temperature to learn. We know that heat affects learning. Improving teacher quality by 1 standard deviation improves test scores by about 10% of a standard deviation. So this implies that HVAC upgrades are equivalent to increasing teacher quality by 33% of a standard deviation. That's a huge effect, right? And we also know that the average HVAC upgrade costs are about $267,000 per school. And the average school size for schools who upgraded their HVACs is about 1,100 kids. So this implies a spending of $239 per student on HVACs with a test score improvement of 3.3% of a standard deviation. I also find that spending $239.41 on non-HVAC related things, all the other things we spent ESSER money on, would only be associated with a 14% of a standard deviation improvement in test scores. So actually horse race this, spending on HVAC versus spending on anything else using the ESSER money. And compared with non-HVAC per pupil expenditures, HVAC-related expenditures were strikingly effective. It's actually the most effective thing we did, or at least in North Carolina they did during the pandemic, was improving their HVAC systems in schools, because it turned out that like the only other thing that had even slightly strong effects were the tutoring programs. Just to conclude, I want to mention the policy implications of this is that we need to be locating these TRI sites and other polluting sites away from population dense areas, since locating these sites near children is very costly. We also need to locate schools, daycares, and after-school programs, doctors' offices, athletic fields, and other places that children and pregnant women congregate away from TRI sites and other sources of pollution. The cost of industrial pollution is much higher than previously imagined, so it's also worth considering regulating this type of pollution by, and basically the MATS rule is gone, but we could bring it back and actually regulate lead and mercury in our air and water a little bit more. And that would probably be good too. So, all right, I will conclude there. Thank you very much. I will open myself up to questions.